Story 1. The largest individual object in the known universe is the supermassive black hole TON 618. Although it is a black hole, it shines brighter than its host galaxy and is approximately 1,000 times as bright as every star in the Milky Way combined. Story 2. The Sun makes up more than 99% of the mass in our solar system. Even in our own solar system, we are insignificant. Story 3. Astronauts have reported that space smells like a combination of burnt steak, gunpowder, and welding fumes. Story 4. The first black hole merger detected by the Laser Interferometer Gravitational Wave Observatory released 50 times more energy than the total energy emitted by all the stars in the observable universe. This extraordinary event, observed on September 14, 2015, involved two black holes, each about 30 times the mass of the Sun, merging in a fraction of a second. The merger produced a final black hole with a mass of 62 solar masses, with an energy equivalent to 3 solar masses converted directly into gravitational waves which traveled 1.3 billion light-years before being detected, causing spacetime to wobble in length by 1 × 10 to the negative 21st meters, or 1/10,000th the width of a proton. The Laser Interferometer Gravitational Wave Observatory now routinely makes measurements that are some of the most precise achievable on Earth, basically at the limits of what is possible because of quantum mechanics. Measuring changes in distance at 1 × 10 to the negative 21st meters is the equivalent of detecting the width of a human hair, 100 microns, in over 4 light-years. Absolutely astonishing engineering is required. The next generation of gravitational wave observatories being developed will be space-based, called the Laser Interferometer Space Antenna. On August 17, 2017, the Laser Interferometer Gravitational Wave Observatory in Virgo, another gravitational wave detector, both observed 2 binary neutron stars colliding. This event was first detected in gravitational waves and then also detected in gamma rays by the Fermi Gamma Ray Space Telescope, and subsequently observed in visible light where ground-based telescopes conducted spectroscopic measurements of the collision which took about a week to fade. Scientists measured several Earth masses of gold, platinum, and other heavy elements from this collision. This was one of the first direct observations confirming long-standing theories of neutron star collisions producing these heavy elements. The era of multi-messenger astrophysics has arrived. Story 5. You cannot burp in space. If you try and succeed, you will vomit. Saturn would float in water because it is less dense than water. Story 6. You can fit every planet in the solar system, including Pluto, between Earth and the Moon with room to spare. Story 7. In the Sagittarius B2 molecular cloud, there is a 288 billion mile-wide cloud of ethyl alcohol that could supply every person on Earth around 1 million bottles of vodka per person per day for close to 1 billion years. Story 8. When the Earth passes between the Sun and the Moon, it is called a lunar eclipse. When the Moon passes between the Earth and the Sun, it is called a solar eclipse. When the Sun passes between the Moon and the Earth, it is called an apocalypse. Story 9. There is no definitive end to the atmosphere. It gradually becomes thinner the higher you go. Space, starting at 100 kilometers, is defined by convention. Space is not a perfect vacuum. It is very close to 1, but all of space contains a very low density of particles. Story 10. As popularized by XKCD, if viewed from Earth, the Sun going supernova would be over 1 billion times brighter than a thermonuclear bomb being detonated directly on your eyeball. Story 11. Faster than light or near light speed travel would create a gravitational time warp. A journey to the center of the galaxy and back would take about 30 days from the cruise perspective, assuming a constant 1g acceleration. It would be 30,000 years on Earth. Galactic civilizations would also be challenging for this reason. Not only would time pass faster, causing technology and society to progress faster on certain worlds, simple communication would be almost impossible. Imagine a caveman appearing today and saying, "I got a message from the chief." Story 12. I love these threads. Space and time switch their roles inside a black hole. The singularity is not a position in space, it is a point in the future. That is why nothing can escape from a black hole. To do so, you would have to travel backwards in time, which requires exceeding the speed of light. Jupiter is so massive that it and the Sun both orbit a point outside the Sun's surface. Global Positioning System satellites would not work if we did not account for time dilation. When the Milky Way and Andromeda galaxies merge, the odds that any two stars will actually collide are infinitesimally small. There are mountains on neutron stars that are only a few inches tall but as massive as the highest mountains on Earth. Space itself is expanding, and the expansion is accelerating. We do not know why this is, but about 20,000 stars per second cross the cosmic horizon, which means they are moving away from Earth faster than the speed of light, so their light will never reach us. In the far future, beings on Earth will not be able to see anything outside of the galaxy. I am just a nerd interested in this stuff, so if anyone educated on these topics sees any errors, please correct me. Story 13. Space and time stretch and warp around massive objects, and light follows these curves, bending as it travels. Around a black hole, there is a region where light can orbit stably. If you were in this region and looked towards the horizon, you would see the back of your own head after it has orbited around the black hole completely. Story 14. Space is not exactly cold. Cooling equipment is very challenging. You need large heat sinks to keep space equipment cool because there is nothing around to transfer the heat into. Story 15. The biggest danger from exposure to vacuum is asphyxiation, not freezing, exploding, or anything else dramatic. Short exposure is survivable. This was reasonably accurately portrayed in 2001, A Space Odyssey, when Dave had to return from the shuttle with no helmet. Just do not hold your breath like he did. Story 16. Space is big. You just will not believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it is a long way down the road to the chemists, but that is just peanuts to space. Douglas Adams' The Hitchhiker's Guide to the Galaxy. Story 17. If two galaxies collided, they would most likely pass through each other without making contact. Story 18. Venus is the hottest planet in the solar system, even though it is the second planet from the Sun. Story 19. It can be 5,000 degrees in space, and you can still freeze to death. Particles can be that hot, but they are so few and far between that there is no heat. Story 20. Cold welding is a phenomenon in space where two pieces of metal spontaneously fuse together without heat or melting due to the lack of an oxidizing atmosphere and the high vacuum environment. This can lead to unforeseen mechanical issues and malfunctions on spacecraft. Mechanism. In the vacuum of space, the protective oxide layer that usually forms on metal surfaces on Earth is absent. This allows the clean metal surfaces to come into intimate contact, creating a bond through atomic forces without the need for heat. Story 21. The Sun is white. Our atmosphere distorts its color. People in space actually see it as white, but it is still shown as yellow in space movies to avoid confusing the audience. Story 22. Jupiter's moons are all named after the people with whom Jupiter had extramarital affairs and the children resulting from those affairs. The first probe dedicated to Jupiter was named after the person who discovered and named many of Jupiter's moons, Galileo. The second probe dedicated to Jupiter was named after Jupiter's wife, Juno. Story 23. Light takes about 8 minutes to reach us from the surface of the Sun, but about 200,000 years to reach the surface from the center. Story 24. Every time I am urinating and a sunbeam comes through the bathroom window, I think about how many thousands of years, from my frame of reference, those photons spent escaping the Sun only to end up bouncing off my body. Story 25. Space is big. Even with a hypothetical light drive flying at the speed of light, Pluto is 5.5 hours away. The speed of light. Our closest star is 4.3 light-years from us. At the speed of light, it would take 4.3 years to reach it. So let's increase the speed. Let's say we can go 4.3 times the speed of light, 4 1/3 times the speed of light. Now the closest star is only 1 year of travel. Not good enough. Let's try 100 times the speed of light. Our closest star is now a little over 4 days away. Let's increase it to 1,000 times the speed of light, 1,000 light-years in 1 year. There are 270,000 stars to travel to, though some still take a year to get there. Should I mention that the distance between galactic arms is between 50,000 and 100,000 light years? At that speed, we're talking about 500 to 1,000 years to traverse the gap between the arms of the galaxy. Perhaps we can increase faster than light travel to 1 million times the speed of light. At that point, we're talking about a few months of travel to the arms of the galaxy. And then someone has to mention the million light years between galaxies. Space is big. Story 26. There are places in space that taste like raspberries, and other parts that smell like burnt steak, gunpowder, and rum. Some places taste like licorice. Story 27. In space, and in fact everywhere, particles and their antiparticle pairs are continuously popping into existence, reacting with each other, and disappearing. As long as the total energy of their existence is below Heisenberg's uncertainty limits, no natural laws are violated. However, if this pair happens to exist on the brink of a black hole's event horizon and one of the particles falls in, the other particle is free to go. This is Hawking radiation, and it is a method by which black holes might evaporate. The time taken for the largest known black hole to do that is approximately 10 to the power of 100 years. Story 28. If you are traveling at different speeds than another observer, you would measure each other's physical dimensions in the direction of travel differently due to length contraction. Story 29. There is a hypothesis that the universe is the four-dimensional equivalent of round. So if you ever got to the end, you would basically just start moving around the three-dimensional perimeter and move to a different spot in the universe, even though it would seem like you were still going straight. Story 30. A 500 milliliter bottle of water would take about 10 hours to freeze in space due to poor heat transfer in vacuums. On the other hand, while I was not able to model this precisely, 500 milliliters of loose water would freeze in milliseconds after evaporating and increasing its surface area by millions of times. Story 31. If someone flew a spaceship at the speed of light, which is impossible but considered hypothetically, the ship would appear as a completely flat disk to an outside observer. This is not an illusion. Objects traveling at relativistic speeds experience length contraction. Story 32. The Earth does not actually take 24 hours to complete a single 360-degree rotation. 24 hours is the time it takes for the Sun to be directly overhead and then directly overhead again. Because the Earth is also orbiting around the Sun, it needs to rotate slightly more than 360 degrees to complete one solar day. The time to complete a 360-degree rotation is about 23 hours and 56 minutes. This is known as sidereal time. Story 33. It is hard to imagine the scale of large stars. If the Sun were a ball 1 foot in diameter, the star Uy would be a sphere as tall as the Willis Tower or the One World Trade Center. Story 34. These photons from all the stars, even those from stars a billion light years away, have traveled that vast distance and landed on our telescope. It is amazing. They traveled for eons. But to the photon, it was instant. Photons travel at the speed of light, and at that speed, time does not move. So they do not experience time. They left the star and reached our telescope instantly. Story 35. Space has a smell similar to burning metal, which welders routinely detect. Astronauts experience this odor fresh off a spacewalk when they remove their suits. This may be caused by charged particles striking the suit at high speed. Story 36. Andromeda Paradox. Two observers are looking at the Andromeda Galaxy at the same time in the same place. One observer is stationary. The other is moving. Both observers observe the Andromeda Galaxy at different points in time, days apart. Story 37. There are more hydrogen atoms in one molecule of water than there are stars in the entire solar system. It is really incorrect, I know. Story 38. I don't know if it sounds fake, but I have always found it almost science fiction that we can see into the past when we look at objects such as galaxies and stars that are very far away. Recently, I searched for a visible star in the night sky that was as far away in light years as my birthday and looked at it. I couldn't help but feel amazed that the light I am currently seeing began when I was just being born. Maybe it's just me, and it might sound silly, but it feels truly incredible. Also, the sheer size of the universe and the visible universe is astounding. Looking at the famous Hubble Deep Field photo always makes me feel a bit overwhelmed and nauseous. Story 39. Astrophysicists and astronomers have mapped dark matter and dark energy in a way that suggests our universe is bubble-shaped. They also believe that the mapping of dark matter and dark energy indicates the existence of other bubble universes touching ours. Story 40. If the country of France did not exist, then the moon would look bright red during a full lunar eclipse. It already looks red, but I like to imagine a world without France. Story 41. You can fit every planet in our solar system comfortably between the Earth and the Moon. Meanwhile, the Sun is almost twice the diameter of the Moon's orbit. Story 42. The universe is constantly expanding, so if you travel far enough, you can never return. It is impossible because any distance you cover will be nullified by expansion, and the natural movement of the universe will make pinpointing the destination impossible. Story 43. Our solar system moves around the center of the Milky Way at 514,000 miles per hour, taking 230 million years to complete one orbit. This journey is so vast that the last time we were in this position, dinosaurs were just beginning to roam the Earth. Story 44. The largest known star is so big that if you replaced our Sun with it, the star's edge would extend beyond Jupiter's orbit by a large margin. Story 45. Any skin contact with, or even worse, inhalation of lunar dust would be very harmful to your health. The lack of erosion means it consists of tiny razor-sharp shards of regolith that can cut into your soft tissue. Story 46. Everything you see in space is in the past. The farther away it is, the farther in the past you are seeing it. Story 47. Not strictly a space fact, but Arthur C. Clarke, the science fiction writer, came up with the idea of a geostationary orbit and that we could put communication satellites there in 1945. He calculated and figured out that 3 satellites are enough to cover the entire Earth. The first truly successful geostationary satellite was launched in 1963. Story 48. The core of our sun is hot enough to fuse the amount of hydrogen necessary to explain the sun's output. The difference in energy is that the hydrogen atoms are close enough for quantum tunneling to occur, allowing the hydrogen to fuse anyway. Story 49. There is a massive cloud of alcohol in space called God's liquor cabinet. It is 1,000 times the size of our solar system and is said to taste like raspberry rum. Story 50. What is this? A question not about sex. I'll just wait a few minutes, and there will be, what lesser-known fact about space sex sounds fake, but is totally true? Story 51. There is an unusual characteristic we believe exists regarding black holes. The larger they are, the less dense they become. Calculations for the known universe show that based on our currently estimated mass and diameter, the universe also fits this same ratio. Therefore, reality as we know it could be one colossal black hole. Story 52. Space smells like gunpowder, ozone, and burnt steak. Story 53. If you were sufficiently far outside the Milky Way, you would barely be able to see anything at all. Outside of a galaxy, there is almost no light. Story 54. The center of our solar system, that is, the point about which every body orbits, is actually not in the center of the sun. In fact, it is slightly outside the mass of the sun altogether, mostly due to Jupiter. This point moves depending on where the planets are in their orbit. Story 55. You can go in a straight line basically forever and you will never hit anything. Space is big, really big, and the amount of matter in it is insignificant. Story 56. It is unsettling that there are rogue planets not part of any solar system. They travel through space alone. It must be extraordinary to be on such a planet, in complete darkness without a star to create day and night cycles or seasons. Story 57. The Andromeda Galaxy and the Milky Way are on a collision course. When they crash into each other, the chance of moon-sized objects actually colliding is close to 0%. This shows how empty space is, even within galaxies. Story 58. The Milky Way would taste like raspberry and smell like rum. Scientists discovered ethyl formate in the Milky Way, which is what gives raspberries their distinctive and sharp taste. Story 59. A magnetar's magnetic field is so strong that if the sun were replaced with one, the magnetic metal in your body would shoot out toward the magnetar. This would be true even if you were farther out in the solar system, such as near Saturn or Jupiter. The extreme phenomena from neutron stars and magnetars are remarkable. I would be terrified to be anywhere near them, much more so than being in a system with a black hole. Story 60. The Sun is not the center of our solar system. No, this is not a conspiracy. No, I am not promoting geocentrism or pseudoscience. This is actual scientific fact. The Sun's gravitational influence on the solar system is massive because the Sun is massive, accounting for 99.86% of the mass of the entire solar system. But the mass of the other objects, such as the planets, asteroids, and moons, also affects the Sun. This shifts the center of mass of the solar system away from the center of mass of the Sun. This is called the barycenter, and it is the true center of the solar system. At times, the barycenter lies even outside the surface of the Sun, causing the Sun to wobble around the barycenter. Story 61. One of the coldest places in the entire solar system is the night side of Mercury. Assuming the heat death of the universe theory is accurate, even though we are about 13 billion years after the Big Bang, that is only in the neighborhood of 1 billion years. The heat death of the universe will not happen for 10 to the power of 100 years, which is still about 1 trillion times longer than the universe has existed until this point. Even if we manage to invent near-light-speed interstellar travel this very year, it will be impossible to physically venture farther than our local group, or maybe slightly farther, or communicate with aliens outside of that range just because of how fast space is expanding. So basically, even though we can see billions of galaxies, all but about 50 of them are already permanently physically impossible to ever reach with light-speed travel. Story 62. There is a region in space called the Boötes Void. It has a radius of 330 million light-years and contains only 60 galaxies. 60 galaxies in such a large area means it is basically empty. Story 63. You can fit all the planets of our solar system in a single line in the space between Earth and the Moon. Still trips me out. Story 64. It probably goes on forever with infinite matter in it. The observable universe refers to the part close enough to us that its light can reach us. There is no edge of the universe. It just keeps going. Story 65. Space is big. You just will not believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it is a long way down the road to the chemists, but that is just peanuts compared to space. Story 66. At noon on the planet Pluto, with our sun directly overhead though far and tiny, there is enough sunlight to comfortably read. Story 67. Do not know if this counts, but even at the speed of light, it would still take 4 years to get to the closest star system outside our own. Story 68. The fact that we appear alone in a vast and ancient universe is terrifying no matter how you look at it. If we are alone, then it is just us, one intelligent species across potentially an entire supercluster or more. If we are not alone, there are other daunting implications. Aliens could be hiding from us, literally by covering the solar system with a spherical inverted television screen, or even by hacking our brains and deleting any memories of anything unusual. Aliens could universally transcend this plane of existence, leaving a lifeless universe behind. Beyond the light of the stars reaching us could be colonization vessels expanding outward just below the speed of light. Story 69. In orbit, if you want to go faster relative to the Earth, you have to burn opposite to your current direction. So, in a way, to accelerate you have to brake. Story 70. Space smells like seared steak. Astronauts say the residue on their suits smells like gunpowder or charred meat. Story 71. Most of the beautiful lights you see in pictures of nebulae actually shift and include other parts of the invisible spectrum, such as ultraviolet, infrared, and microwaves, which make them look nicer. Story 72. There are many more planets than stars or asteroids and comets. It sounds strange, but if you think about it, you can start to understand that space is truly all around us. Amazing. Story 73. There is actually a gradient to space. There are millions of atoms per meter within our solar system, thousands per meter between our galaxy and the others in our cluster, but only dozens between our cluster and the others. Story 74. The moon is tidally locked to the Earth, so we only see one side of it. Due to variations in rotational periods, humans have only seen about 56% of the moon's surface. Story 75. If two metals of the same type touch in space, they will bond permanently. This is called cold welding. It does not happen on Earth because of moisture and oxidation, but in space, in a vacuum and with no atmosphere, the atoms have no idea they are separate objects, so they just bond. Story 76. Energetic particles blast through astronauts' bodies. Sometimes they go straight through their eyeball and light up inside the eyeball itself. They can see this as flashes of light even with their eyes closed. There are photos online of electron microscope images of a space helmet. You can see tiny impact craters and holes blasted through it. Story 77. Since everything is expanding from a center point, the distance between two objects on opposite sides of that center point actually increases faster than the speed of light. Similarly, if you stood back to back with someone and both walked 2 miles per hour, in 1 hour they would be 4 miles apart. Story 78. A bit flip caused by a cosmic ray refers to a change in the binary state of a bit in computer memory, from 0 to 1 or vice versa, due to the impact of a high-energy particle from space. These cosmic rays can disrupt the electrical charge that stores bits in memory, leading to errors or system failures. Therefore, space shuttles have backup computers. Thanks a bunch for sticking around till the end of the video. Remember to subscribe, and until next time, stay awesome and goodbye.